Hello everyone, this is Mr. Bryce reminding you to start where you are, use what you have, and do what you can. A quote by Arthur Ashe. Start where we are. We're on the second part of Unit 3, Lesson 6, which is page 22. If you don't understand what I'm talking about, you can just scan that QR code and listen to the genius who wrote these exercises. Make sure you've already listened to part 1, which you see before you. Right now we're on part 2. Okay, piecewise equations can be challenging algebraically. Sometimes the information we find from them can be misleading. Now, I crossed off or incorrect. There's contradiction, okay? Not incorrect, but there might be a contradiction. Consider the piecewise linear function g of x. When x is less than 2, we have 5 minus x. When x is greater than or equal to 2, we have 1/2 x minus 2. That's how you read that. So you have to know the conditions. This is the conditional statement. If and only if x is less than 2. This is the other conditional statement. If and only if x is greater than or equal to 2. Determine the y-intercept of this function algebraically. Let's write down g of x equals 5 minus x. Now, the y-intercept is when x equals 0. So if we plug in g of 0 equals 5 minus 0, which is 5, that's the y-intercept of the function. Well, wait a minute, Mr. Bryce, there's another equation there. What if I type or calculate g of x equals 1/2 x minus 2? So g of 0 is 1/2 times 0 minus 2. G of 0 equals -2. No, not that. Why? Because of the conditional statement. Okay? The conditional statement says only when x is greater than 2 or equal to 2 can I use that equation. So this is the y-intercept. Find the x-intercepts of each individual linear equation. So think about it. Okay, we know to find the y-intercept, you plug 0 in for x. How do we know that? Well, if this is the x-axis and this is the y-axis, where is it going to cross? What's the x value? Always the x value is 0 for that one. This over here, what do we know? We know that for the x-intercept, if there's the x-intercept for there, if that's the x-intercept, we know it's 0 high. Why? The y value is 0. So 0 equals 5 minus x. Add x to both sides. X equals 5. Or, and we can have an and, because there might be 2 of them. I don't know. 1/2 x minus 2 equals 0. Add 2 to both sides. 1/2 x equals 2. Multiply by 2. X equals 4. Stop. Draw the line. Let's take a look at this. First of all, this equation, x has to be less than or equal to 2. 5 is not. And I'm not even going to do that. I'm going to do this. 5 is not less than or equal to 2. So this is excluded. Some of the times said omit. For the second one, for this one, x has to be greater than or equal to 2. 4 is greater than or equal to 2. So this is the x-intercept. Part C says graph the piecewise function below. So I have the piecewise function here, and I have to graph it here. Well, how do I graph it? X is less than 2. Okay, visualize this. Visualize it. X is less than 2. There's the x equals 2 line. Now, that you don't draw that. Just visualize it. I wish you said that before. I did say visualize before. We visualize that. So that equation, we graph less than 2 to the left. We know the y-intercept is 5. 1, 2, 3, 4, 5. And the slope is -1. Down 1, 1 to the right. Down 1, 1 to the right. Don't plot there. Don't plot where the smiley face is because it says less than. And now we can go the other direction. Up 1, 1 to the left. Up 1, 1 to the left. Up 1, 1 to the left. There's no boundary. So put an arrow there. Stop! That's the bound. Now, it says greater than or equal to 2. We know the y-intercept is -2. Okay, what are you going to do here? This is going to be tricky. Tricky. The y-intercept is -2, and we go up 1 over 2. There, okay? Now I can start plotting. I can't plot the -2 because I can only plot numbers that are greater than or equal to 2, and this is 0, that's 1. Okay, so that's the first point that I can plot. And it is filled in because it says greater than or equal to 2. Then you go up 1 over 2. Up 1 over 2. Don't put an arrow on the left-hand side. That is 1/2 x minus 2. This one is 5 minus x. And together we have our piecewise function. Why does your graph contradict the answers you found in part B? It doesn't because I was thinking ahead. B, find the x-intercepts of each. Okay, so we had to omit points outside the domain How else can you resolve the fact that the algebra seems to contradict your graphical evidence of x-intercepts? Well, stick within the domain. Read. Think. How about start where you are? Use what you have. Do what you can. Stay within your domain. That's where it is. Start where you are. That's the beginning of your domain. Use what you have. That's your whole domain. Do what you can. Find your range. I had no idea that today's motivational phrase would have so much to do with the exercises that we're doing. For the piecewise linear function, find all solutions to the equation f of x equals 1 algebraically. Okay, that's pretty easy. Oh, no. Sorry. This is the y number. So that means I have to have 1 equals -2x plus 10. Subtract 10. 9 equals -2x. -9. Divide by -2. 4.5 equals x. Is 4.5 less than 0? Omit. O-M-I-T. Sorry about that. We omit that. Why is it 2 different colors? Because I just looked up how to spell it. We omit it because it's outside the domain. So now I'm going to do the other one in blue. 1 equals 5x minus 1. Add 1 to both sides. 2 equals 5x. Divide by 5. 2/5 equals x. It works because 2/5 is greater than 0. 2/5 is greater than 0. So it is in domain. Find all solutions to the equation algebraically. Okay, so the solutions, I wonder if it wants We can say that it's 2/5. That's it. Why? Because it gave us the y. It wants to know what the x is. We can write it like that. We don't have to write it as point. Ladies and gentlemen, 10 minutes are gone. We're done with this page. If you have any questions, make sure you ask me in class. It's been fun. See you later.